Video 2 of the Git Essentials workshop deals with Git Objects. First, let's talk about the Git Objects identification and then about the four different types of Git objects: the blob, the tree, the commit and the tag. A Git repository is stored in files with names of all the same 20 bytes length. This gives 40 hex digits split in starting 2 digits for a directory and the rest as a file. The SHA-1 is a worldwide unique number. But fortunately, commands accept some few unique digits. Git objects may be compared just by name. Identical objects have identical names in any repository. This leads to a very high security level. No undetected bit errors, no undetected fakes. All Git objects have 3 elements: a type, a size, and content, where the content part depends on the type. We are going to discuss now the 4 Git object types. A blob stores application data. A tree is a directory. A commit is a pointer to some tree with metadata. And a tag is a nicer name for a commit. A blob is a storage for the contents of some file. It never changes. The blob name is its SHA-1 number over the Git header and the file contents. It's nothing more. It does not even hold the file name. Since a blob is entirely defined by its data, if any 2 files in a directory tree have the same contents, then they will share the same object, the same blob object, and this is a very important fact. Therefore, Git is also said to be a content-addressable file system. What are the metadata of a blob? Its attributes. Now, we have an object type, the blob length, the blob contents itself, and the SHA-1 number stored at a given location in the file system. Note, the first 2 digits are reserved to be stored in a directory. The contents that is stored in a blob could be retrieved by the git show command. Let's emphasize that a blob has no file name. A blob usually is created with the command git add file. Note that this takes place before any commit. We could also create some Git object with a single command. Echo test content into the pipe of git hash object. The generated SHA-1 is shown on the standard output. If this SHA-1 does already exist, there is no need to create a new one. And this operation is the same anywhere on the world. We could list all objects with find and search for the generated blob in the output. Finally, we could analyze a blob object, for example, with these Python commands. Of course, this is never needed, but interesting. The tree object represents a directory entry in some file system. The SHA1 name depends on tree contents, including metadata. The metadata is a list, and this list holds items which may be one of two types. For file or symlinks, this item is a blob, and for a directory, this item is of type tree. Every list item has also a plain name for the file or directory. Note, this is not a path, but just a name. And finally, there is the mode with Unix file permissions for every list item. And because tree objects may contain other tree objects, this is a recursive definition. One and the same tree object with a unique SHA1 ID may be reused at several places. And identical trees may quickly be identified by their name. The third type of Git objects is the commit object. It is a reference to a single tree with additional metadata. In fact, it is a snapshot of a complete file system at a given time. The history is modeled with a single linked list of commits. Single is you may look backwards into the history, but of course not forwards into the future. A commit contains just several pointers and metadata. Essentially, this is the SHA of the referenced existing top-level tree object, the list of parents, the author, committer and timestamps, as well as the commit justification or description. And yes, the contents of a commit object may be displayed. The git show command gives us all about the Git object. Let's have a look at a small example. The top-level directory contains two elements: a README file and another directory, lib. The lib directory again has two entries, a file and another directory, inc. And the last directory, inc, this here, only contains another file. And finally, the complete existing snapshot is referenced by the commit object. And finally, a tag is an object which is a pointer to a commit. It gives a commit a friendlier name and has also a message or justification like the commit itself. At first of the metadata there is a commit SHA where the tag points to. Also stored are the tagger, the creation timestamp and a message. Keep in mind that as a reference to a branch, a tag cannot move and also cannot be checked out. but you always can create a new branch at a given tag. Let's finish this session with lightweight tags. These are no objects at all, but just references. So, what's next? Thanks for watching, and you are invited to attend the follow-up video Git Terms and Concepts.